In this video, I'm gonna show you how to use Excel SPSS. Oh, I'm sorry, Excel data analysis tool pack for to do the T-tests, student T-test, as well as the ANOVA test. So let's pick a outcome variable that we're interested in, and I think in this case income is probably going to be the most interesting for us. Here's what we can do. We can take income, and what I suppose that it's going to be easier to do if we just took maybe like 300 cases first, because it's a big data set and we don't really want it's just easier for demonstration. Okay, you can do it with as many variables or as many observations as possible, but just for the sake of demonstration, let's use some of these observations. So here's the number of the participant. Doesn't really matter, and I think what in our case might help us. And so if we do T-test, remember independent sample T-test, it's when you have two different categories, for instance male, female, or in this case yeah, let's do income category, I guess. So it's one of the variables with two attributes. So, and again, see, it comes out as reference because it was recoded, remember, and it was and it contained formula to recode. So what we can do instead, we can paste as values, and then it's values. See, there's no formula. There's no formula here, and here, if we go here, it's formula. Okay, so it's always easier, to save it as values. So now we have those two categories. So say we want to check if the income levels differ for high income or low income category. This is not natural, okay, because we don't want to. This is going to be like a huge difference between them, right? Because this variable actually is a representation, or this variable is actually a representation of this variable. So let's just take maybe either marital status. Marital status has two categories, right? And then there should be gender status, gender somewhere, which I don't see. So let's do marital status, okay? So this, and we only need the first 300 participants as we agreed in the beginning of this video. So let's see if the incomes differ based on whether a person is married or not. So here. So instead of income category dichotomous, we use marital status, right? So marital status has two attributes here, married or unmarried. So before we start our analysis, it might actually help to use pivot tables for these guys. And let me just delete this so that it doesn't bother us here. So let's check how the incomes differ based on whether a person is married or unmarried in this particular sample. So let's do descriptive on average income based on whether you're married or not. So to do this, remember, we have to highlight and we have to insert pivot tables. And in the past, we had inserted pivot tables in a separate worksheet, but here we can identify that it's existing worksheet because the sample it's only two variables here. So I pressed on existing worksheet, then location, and I identify this as a location. And remember to use hit OK, and here we have the pivot table, and we want to see if the person is married or unmarried, and what's their income. So this is sum of income, which is not helpful. We want to see what's the average income based on whether you're married, when a person is married or not. And we just remove unnecessary decimals here. So we see that for married people, income is pretty much higher than for people who are unmarried. But can we infer that this would be true for population? So to do this, we need to run a t-test. So for t-test, we use the data analysis toolpack. So data analysis toolpack. I hit data analysis here, and we do the t-test, and we do t-test of a 2-sample t-test, assuming equal variances, but to be on the safe side, we didn't check any, we didn't do any equal variance testing, so we do the unequal variance in this case. So I hit OK, and now we have the ranges, right? So the range is basically your categories, right? So the thing here with Excel is that in order to do a t-test, you first need to you have to have ranges of data that correspond to the certain category. So in this case, let me get out of here. So in this case, you need to sort this variable into to have all married first or all unmarried first, and then you can do the test, and I'll show you how to do it. So there are two ways. You either sort and select, or you create two columns, one for married and one for unmarried, and insert all the observations here, all the income values in there. But in this case, because it's not too difficult, what we can do is we can sort the data set. So let's say expand selection, and here we just say that we need to sort by marital status, and A to Z. Well, A to Z is fine. So all the married people are going to be here, and all unmarried people are going to be below. So these are our range, because Excel understands this. Okay, Excel understands that this this particular value corresponds to somebody who's married. So you have to do it this way. And what we do is we go to data analysis and to sample unequal variance, and here what we need to identify our first range, right? So our first range would be from here until we get to those people who are unmarried. There. So the first 146 observations. We got it, and now for variable 2 range, we select all people who are unmarried. So this is group 1, this is group 2. Group 1 is married, group 2 is not married. And then label, oh no, we don't have labels, and alpha level is 0.05. Hypothesized mean difference, and it depends on whether you do one-sided or two-sided t-test. In our case, it's two-sided t-test. We want to understand whether there is a difference between incomes based on whether you're married or not. And yeah, and we can do output range. Let's go up here. So let's do output range here somewhere. Okay, and I hit OK. Okay, so yes, that's fair enough. I haven't done this in a while. So, so the thing is that the input range, the variable 1, because we've already identified as variable 1, we don't have to select married. So we only have to select the values for income. So I'm just going to select this, and for second is all the values for unmarried people. There. And now it should work. So the output range we've identified, and hit OK. So if we go up here to our output range, we'll see the results of our t-test. And here's the results of our t-test. There's too many decimals here. Oops. So we see that married people on average make $84.4 thousand, unmarried people $77.9. We have about almost the same number of observations. Hypothesized mean difference is 0, that there's no difference, and degrees of freedom and t-statistic is pretty small. We want a two-tail p-value, and the p-value is pretty high. So even though initially we see and we think that there's a significant difference, statistically speaking, the difference is not significant. So we see that the t-statistic is pretty small, it's pretty meager, and our p-value is higher than 0.05. In a similar manner, you do the ANOVA test, but ANOVA test, as you remember, involves more than 2 categories. So say we have so we have 3 types of cars, right? So let's do the cars example, the car category example, and we can choose first 300 observations here, and I'm gonna copy and paste into our spreadsheet here and paste it here. So in this one, oops, didn't want to delete it, just didn't want to get some space here. So let's say delete this one. So let's say we look at how, if there's difference between income levels based on whether the person drives a luxury economy or standard car. So it's done in a pretty much the same manner. And to run an ANOVA test, you would have to put your variables here or in observations in a table format that Excel's going to understand. Just getting some additional space here. So what we can do, we can again sort the data, and we can sort the data based on car category. And we see that there are 3 car categories: economy, there is standard, and there's luxury cars. Yeah. So we take all the economy cars here, and we paste it over here, and then we take all the luxury cars, all the income values for those who drive luxury cars, we insert them to the luxury category, and then we also have the standard ones, and the standard ones belong here. Okay, and now we just run the ANOVA test, which is pretty easy to do. We check ANOVA single factor and select this all and labels in the first row, and can do the output range. Oh, sorry, output range here, for instance, and I hit OK, and here we have the results of the test. And you see that there's count, there's sum, there's average, what's more important, right? And there's variance as well. We have a bit between group.